Tumelo Tlhapo, the voice behind I Said Robotics. Thank you so much for participating in today's session. Please don't hesitate to email us, or I almost said WhatsApp us. So maybe with the subject line of your relevant topic that you'd like us to address. We are very good when it comes to replying to emails. Thank you so much once again for tuning into today's session. Without wasting any time, I'll hand over to Meneer Johannes and keep your eyes glued on the screen.
Thank you so much, Tumelo. Welcome everybody to today's session. It's the 4th unit of M2 of February. February is almost gone. Can you believe it? We only have a few small house rules for today. We'd like to ask everyone to please mute your cameras to save data and bandwidth. Also to mute your microphones to keep all the background noise to a minimum. If anybody has a question at any point in time, please feel free to raise your hand. And if you have any inquiries, please, Tumelo just dropped the email in the chat area. And then over to you, Dr. Gous.
Awesome. Thank you, team. Thank you. Yes, we're on unit 4 already. I'm going to just change. This is the chicken. This is the chicken in the competition. But let me just maybe show my face. Turn the camera around and I'll show you my face. So it's really exciting to be at unit number 4. For those of you who've done M1, we kind of started right from the basics. We built the robot. Some beautiful music. Okay. And so we started just building the chassis, doing basic navigation programming, did some basic problem solving, and then suddenly we were on to M2. So M2, we kind of first upgraded our programming. We did sensor readings and lots of discussion, for which I'm very grateful. So we did sensors, adding sensors using loops and decisions. And then yesterday we did some gearing, very important concept for the efficiency of building a more effective robot. And you'll see also in most of the big robots, gearing is one of those important things. If you get it right, you get mechanical efficiency, you get mechanical advantage. And so gearing is definitely a whole topic on its own. I feel like it's not really being justified, as in unit 3 or 4. But anyway, there we did have that. And then we had powered attachment. So what I want to do today, and I'm grateful that Tumelo started the discussion, because we were in the mode of discussion as we're pulling it all together. And I want you just to maybe ponder that how far you've come and how far how much material we've covered in the last 4 days. So what we're going to do now today is we're going to just talk about, we're doing brainstorming, and I'd like some discussion quickly, and how quickly you're going to know what the answers are. So if I'd done this presentation, maybe we should have done a before presentation. If we'd presented these for discussion, like right on Monday before we started, you would have thought, like, what is she talking about? And yet, where we are now, you have the answers, and you might not be able to implement it, but you know in which direction then to guide your students. And then I'll end with saying, okay, but now there's M3, and so that's the next level. All right. So I'm going to just do a presentation. We're going to pull it all together, and then I managed to get this camera to work. So we're going to do some practical stuff, and I want to show you kind of how to unpack a problem, and then how to continue, and that's where M3 comes in. So if you think you're finished, you're not. You just keep going. All right. So let's do the presentation first. And as usual, I need to share my screen. And it's one of those things. And now I can't see anything. So my camera's on. I don't know. Does my camera stay on whilst I'm presenting?
Yes.
Yes,
It
Dr.
does. Oh, okay. All right. So you can still see me?
Yes.
Oh, okay. There's my presentation now, and we're going to, there we go. A presentation visible?
Yes, Dr. Gous.
Awesome. Okay, so this is part 4, and what we're pulling together now is we're pulling together everything that we've done. So we've now not only one sensor, we've somehow got multiple sensors. We've got the flow control in the programming, we're adding gears for the structure, we're adding power attachments, and it all pulls together to make then one solution. And if I have one more person phoning me for a funeral plan, yeah, never mind. Okay, let's just carry on. Okay, so this is Unit 4. It's like the end of an amazing race, and the tribe has spoken. You're good to go, and you're good to carry on with M3. All right, and of course, our whole class culture is really to equip our educators. If we want to have competent and confident teams of learners in robotics, we need to equip our educators or any coach. So whether you're an educator, a student, a trainer, facilitator, or just a visionary community leader, this is the place for you. All right. Okay, so what we're going to do today, and I encourage you to have pen and paper handy, and let's just kind of unpack things. Because we're going to analyze problems, and this is not a session where you sit on a couch and you pour out your heart. This is analyzing the problem ahead of you. All right, but this kind of problem is we do need to divide and conquer. Okay, so we've got this huge problem in front of us, and then we divide it up into we call it increments. Okay, so normally we kind of you have, what are the programming increments? What are the building increments? How do we move? How do we improve? How do we combine? And then we test. Okay. So all things always divide and conquer. Okay. So this is my little plan of action. Not cast in concrete, but it does work. All right. So if you have a problem, you analyze the problem. And usually it's good practice to go and see whether you can find any other information about it. All right. Gather information, define the verbs. So in robotics, your verb is your important thing. Your verb will tell you exactly what is required to do. Remember, your robot is going to do something. So you need to analyze the verbs. And the verb will give you an indication of the structure required. I've put in there role playing. This is part of the drama part. It's good to play the roles. If I was the robot, where would I go? What would I do? How would I drop? And get, I'm going to show you some now right at the end, where you put in your hand and say in your hands what you're going to do, or as a robot, what would you do? And then you look at those movements, look at the verbs, and then you can come to a solution. But brainstorming is important. Please do not accept the first learner's answer. Okay, it's got to be a team approach. Okay, so if you've got the problem and you've got it in your head, then the first thing is, okay, so what kind of structures do we need? Do we need attachments? Are we going to get away with passive attachment, or do we need a powered attachment? And if we've got a powered attachment, do we need to add some gearing? Okay. Do we need sensors? Are they required? Please don't add sensors just for the sake of making pretty. No, you need to say, why do we need sensors? How are we going to attach it? And how are we going to use the sensor data? If you're not going to use it, please don't attach it. All right, so now we've got the structure going. Now we say, okay, what about the programming? Is there movement? Okay, does the robot need to leave base? Does it need to get somewhere? Well, that's the movement. If it's the whole robot, that's fine. Is it just an attachment that needs to be moving? Is there anything that is linear, anything that is repetition, or is there any decision that is it this and then this and then this? Or can we analyze it and say, no, there's actually a decision. You go forward, and when you see this, then you stop, and then okay. So then if you've got the flow control, do we control the flow control with data from your sensor? Okay, so just keep this. So we take the problem. What are the build structures? What is the programming? Okay. So let's have a look at some applications. I said to you, this is analyzing it. Okay, so we divide the challenge. We're sure that we're trying what we're trying to achieve. We always have an initial attempt. You're never going to use the initial attempt. You're going to keep testing it, keep modifying it, keep improving it. And that is the important thing about robotics and learning in this case. It's a forgiving system. And you always have an honesty evaluation and say, maybe we can do better. Maybe we can improve. And then also to be honest to say, no, this is how we're going to leave it. Sometimes when something is working, leave it. You don't need to modify it. Okay. So I'm going to discuss some applications of learning, and whenever you go and look at a video, this is also the mat that Tamela shared. It's a WRO mat from the 2021 WRO challenge. Okay, and and you're welcome to go and watch this video. But basically for WRO, you get a list of things that the robot has to be able to do. All right. So it has to pick up things. It has to deliver things. It has to move things. It has to collect things. It has to take things. So there's a whole lot of verbs in there. However, there is a plan. So it can't drop before it's picked up. Okay. And what I really encourage you to do is to see, watch the robot. You don't have to create it. Just watch the robot, and then you start analyzing. You can do powered attachments. You can do line follow. You can attach a sensor. You can build a powered attachment. You can. So you can do all the requirements. It's just putting it in the correct order to do the correct missions. Okay. A lot of fun. The 2021 was yeah. Okay. So here's a really cool one. So if I tell you what it has to do, you'll think, I can't think. All right. The robot has to climb a pole. Goes up the pole, and if you watch the video, it's got ping pong balls at the top of the tunnel, or at the top of the tower. It's got to fetch the ping pong balls at the top of the tower, come down, follow the line between, and there's another tower in the same line. Okay. So let's analyze it. What do we have to do? We've got a color sensor, and it's reading green and blue, and you can see the top is red. When it gets to red, it has to stop. A color sensor. All right. What is the movement? The robot has to move up a tower. How's it going to move? Tires to hold on. Okay. So if you look at a video and you think, I can't do this, but analyze it rather. So there's this whole collection of videos that you can do. All right. Now I'm going to stop talking. Or maybe I'll do one more. Okay. So this one was, it had to turn. It was also a WRO challenge, but it had to turn. These were solar panels. See the little structures on the intersections? They are called solar panels. The ones that are made with black bricks are the ones that need to be replaced. And then the green and the blue, that was correct. If it was the other way around, it needed to be turned. All right. Straightforward. You've got a color sensor watching for the intersections. The collect structure, or the structure to pick it up, you can see it's at the back there. So it travels over the solar panel, and it picks it up from the back. It picks it up, turns it, and puts it down again. Nothing that you cannot do. All right. It might take a little bit of work, but you've got it. Okay. This is one of those really cool things. The video is also quite cool, because the only brief that they had was the robot had to climb 4 or 5 stairs. That's all. Okay. But the stairs are getting double the height. Okay. And it's got that little ping pong ball was supposedly to be an egg, but we had too much egg smushing, so we just kept it as a ping pong ball. Okay, but it's got to go all the way to the top, and it's got to go all the way down to the bottom. All right. So if you were to think about it, okay, so it's got to go up, it's got to be long. But look at all the teams that came with a solution. Not one solution was the same. Not one. Okay. And every team had their own interpretation. There was one team, low risk team, they only did 3 stairs. But they got points, you see. And so there is this playoff when you have a solution to say, this is what we are going to work with. All right. We are not going to go further. They had color sensors. They had a powered attachment. They had decisions. They made a decision for the robot as well. We're going to only go up 3 stairs, and then we're going to stop. Okay. Okay, but now I'm not talking anymore. All right. So I'm going to ask Tamela and Casper to watch the chat. The problem is a maze with a touch sensor. So I need to know, what are the sensors? What is the flow? Are there any gears required? And are there any attachments required? Okay. Who's going to answer? Tamela, is there any answer in the chat?
No answers yet.
No answers. We need a poll for this. We should have had a poll.
You were reading my mind. I was about to do it. What's the question?
Right. Anybody want to answer this one? They get more difficult, so the quicker you answer, the better. Anybody volunteering?
So kindly please repeat your question again.
I need to know for a robot to complete a maze, this maze. What are the sensors? What is the flow? What are the gears? And what are the attachments required? Anyone? Is there nobody, Tamilo?
There's no one yet.
I'll answer the easy one and then you can answer the next one. Okay, Casper, do you want to answer it?
There's a hand.
Oh, good. Oh, good. Thanks, Nadine. Thanks, Nadine. All right. Who's got the hand up?
This is Cleo. I take it the touch sensor, obviously, because it's a maze, so it has to stop somewhere.
Very good, Cleo.
I'm not
Yes.
sure I'm not sure what's in your maze. Is it a normal maze or what? So I'm assuming if there's objects, there would be a motor sensor also.
It's the picture as shown on the screen.
Okay, then yeah, that's a plain maze. So touch would be how can I say? Motor is one for the obstacles, obviously. So that's the only one I have.
Okay, no, that's fine. That's good. Okay, so we've got motors for the robot to move through the maze. And we've got a touch sensor. So that when the robot touches the side, it must stop and reverse a little bit towards the back and sideways. So it kind of goes around a turn. And then it keeps going forward. And then it goes forward until the touch sensor touches. Then it stops. It reverses a little bit backwards, and then it goes around the corner. The important thing is that the touch sensor, can you see the touch sensor here in the front? That the touch sensor is attached lower than your side of your maze. Okay, very good. Okay, so this is made out of recycled materials, but you could also make a maze out of cardboard boxes as well for the robot to get out the maze. And then obviously it would be to how quickly you would need to get out the maze. All right, so we've got sensors. The flow is it must continue to move until, and maybe you have a color sensor to say until it reaches the red line when it gets out the maze. We don't need any gearing and we don't need any attachments. Well done, Cleo.
See, Eric has got a question.
Yes, I'm listening.
Yes, also, okay.
Hi, Eric.
One of the challenges with this, and I've made a maze using these kitty blocks with the alphabet letters on in foam.
Okay.
And that's quite nice. But the thing with the one challenge I found with this kind of maze is that it helps you if you know the robot has to go left the next time, right the next time. So to build a robot that actually has to find its way through the maze, I would think is challenging.
Kind of like a next level.
Yeah, so if you know that the way you've drawn it here, okay, you've got to go right and then left, you can actually figure that out. You can get the robot to make those moves. But to just put the robot in the maze and say, look, find your way out is difficult.
You know, Eric, I need to add to that. So also a WRO challenge a couple of years ago was they had a maze and they had a lid on it. All right. Okay. So and you couldn't see where your robot was. Yeah. You could also not see the configuration of the maze.
Okay. So how did they do that?
Okay. So what you there's a next level to this. So this is just with the touch sensor. So you would touch if you go forward, then you would go back, but you would be consistent in reversing towards the left. So you don't change. You either reverse to the left or you reverse to the right. Okay. There is an algorithm, and it's got to do with a ultrasonic sensor. Okay. And with your ultrasonic sensor, but this is now not this challenge. And if you have an ultrasonic sensor, in theory, it's called the left-hand or right-hand maze algorithm. So if you keep closest to the wall, you would eventually get out of a maze. Yeah.
I'll try and find that photo of that board that we had.
Okay.
It was a very fun one that we changed it every time a team thought they knew how to do it. We changed it.
Yeah. No, it was lots of fun. And you know, the more I'm thinking about it, the more I'm thinking we need to have like a fun winter school where everybody can sit we'll give you a challenge in the morning and see who can solve it by the afternoon. Eric, thank you for that idea.
Okay.
Awesome. All right. Okay. So this is a touch sensor and a maze. And yes, also one thing to know about mazes is you can't go too fast. Ne? Rather slow and steady gets out the maze. Okay, so the next one is this one. It's again a maze. The blue lines are kind of there just to guide you, but the secret is the blocks, the color blocks. Anybody want to guess how to follow this? Anybody? Is there any hand up, Tamelo?
No hand yet.
No? Okay, so I'll give you a clue. If you go forward and you see yellow, you must turn to the left. If you go forward and you see red, you must turn to the right. Okay. So this is also, you can put any colors down, but you can basically guide your robot just moving from one color block to the other. All right.
I see Michelle says you can use a color sensor.
There we go. Thank you, Michelle. Thank you very much. Yes, indeed. Very much so. You can use a color sensor. You go forward, and depending on what color you're reading, so your flow will then be a loop to say, move until you see one of the following colors. If you see yellow, then you do this. If you see red, you do that. If you see green, you do the other thing. All right.
It's an if and else a good if and else statement.
Yes, very, very much so. It's a very serious. You have to know when if and else is yes, or case statement. Absolutely. But for gears and attachments, you don't need to use attachments for this. All right, let's see what the next problem we have to solve. Oh, okay. So this is a line follow. So you either need to put down white tape on a dark surface or black tape on a lighter surface because you need to follow the line. Anybody want to hazard a guess? How many sensors do we need for this robot? Anybody? So what the robot has to do is as soon as it comes to that box, it has to stop and go around that box and then find the line again. Anybody?
Yeah, I almost wanted to say, I think 2. Or Nishan said, okay. Sorry, Alexander, you just said, we'll use a forever loop or only a set amount?
Yeah, so this one you would probably use forever until it comes back, but there has to be an ending condition. So normally you would have like a red line or a blue line over the white line to say when you see red, that's when you can stop. All right. If you are seeing that there's an obstacle in the course, so then you will need to have an ultrasonic. You see, now we've already got 2 sensors. We've got an ultrasonic facing forward and a color sensor facing down. Okay. Yeah. The other thing is if you go around here, this is kind of the straight. This is kind of your highway. If you go there, that's easy. That's easy line follow. All right. The not so easy line follow is this. So you would need to time how long you are in the bends and go nice and slowly. And then once you're out the bends. Yeah. Everybody okay with that?
Dr. Host, we have an answer from Cleo.
Yes, Cleo.
You already answered it. I was going to say ultrasonic and the color one.
You see how the answer just comes to you.
Yeah.
Yes. Oh, mission accomplished. It feels like mission accomplished. Yes, and you just look at it and you know, all right, we definitely need to have a color sensor down. We need to have an ultrasonic forward, not too high so that it can find the box. And I would probably say you need to detect it about 20 centimeters before you hit into it. So you get time to be able to turn around and around. Yeah. Awesome. All right. So there's our line follow. Line follows are a lot of fun. And it's important that the learners know line follow on the left-hand side, on the right-hand side. The straights are easy. The bends are a little bit more complicated. A 90-degree turn in the road is kind of everybody's nightmare. Okay, so I'm just FYI for that. All right. Okay, this picture's not too great, but it's a oh, there it says, it's a forklift. All right. Okay, so what I really want to show you, so there's no sensors, except that I would have put an ultrasonic at the end of it, so that the forklift knows when it's picked up something. Okay, and it's not very clear on this picture whether there's actually an ultrasonic there. Okay, and then definitely gearing for strength. All right, the attachment is definitely powered because it's got to lift it up. The gearing is the strength part. All right, when you do forklifting, you don't need speed, you need strength. Okay, and an important thing to know is that, so why would you turn the brain and the motors that way? That's about balance. That's about balance and center of gravity. Remember, if you're picking up a weight, you want to have as much straight down force of gravity that your robot can actually pick something up. Okay, so this is not, it's not going to tip. And look at the wheels, they're close to each other. All right, so it's greater stability. Yeah, a forklift is one of those powered attachments, not often used, sadly, but it's got a lot of modification potential. You can definitely use a whole lot of things, making longer and shorter, like almost fork parts onto the forklift. All right. But if your team knows how to build a forklift, much better. Kudos to them. All right. Okay. All right. Let's have a look at the next one. All right. Oh, this is my favorite, my all-time favorite. This is your mechanism, your claw. Okay. So this is a powered attachment. Okay. And I kept the whole page because here's a one as well, which is large attachments versus simple attachments. I need you to look at that as well. So this is a claw and lift mechanism. So it puts it together and lifts it up at the same time. All right. So it comes up and holds it together and then pulls it together. So it's a single mechanism that can do two things. So that is a multi-purpose mechanism that is required. Okay. And I really recommend, oops, sorry, hang on. I really recommend that you watch this large attachments versus simple attachments. There was a time, and I want to say about 2015, 2016, where the teams had super large attachments, okay? Very large attachments to the point that they had a tiny little robot and these huge attachments. Now, that is all very fine and well if your large attachment works. All right. So I'm now pleading with you, make compact, simple attachments that work. All right. You'll get a lot of attention if you have a super awesome attachment. Okay. And if you have a huge attachment, you will get lots of attention. But you will also get a lot of attention if that attachment doesn't work. Right. And that is not constructive learning. So I'm pleading with you. Please encourage your teams to build attachments like this. All right. You can see there's our worm gear. There is our spur gear inside. Can you see, however, that they have pushed it together in a frame? So on the Riley Rover, when we did the gripper gear yesterday, very fragile is the word. Fragile because there's no reinforcement. So in this here, it's a gripper. We've got the worm gear. We've got the spur gears, but the axle is held in place by two of these rectangular structures on either side, holding the spur gear into the worm gear so that there's meshing. Okay. What you don't want to happen is that it just becomes as soon as you use it, it becomes untangled and unmeshed. Also note over here, they've got rubbers at the end of your grippers. Okay, and that gives you just that little bit more hold on the item that you are grabbing. Okay, a claw and lift mechanism it's a good mechanism for your teams to have in their design backup in their head, as mental models. So I'm very for mental models. We need to build a collection of mental models for teams. All right. And I would really, this first Lego League, large attachments versus simple attachments. He knows what he's doing and he knows what he's talking about. And I would just back that up to say, I have seen teams fall. All right. I have seen teams fall hopelessly when they come to competitions with these huge, impressive attachments, and that doesn't work, and that's not lekker. All right, so we're going for simple, functional attachments, impressive and multi-purpose. That's always a given. All right, okay. So definitely this one didn't have a sensor. It just definitely has a flow, because you only remember your powered attachments go on time. So you would say close or go open for a second or so, but that you need to test. Gearing is important, and this is a powered attachment. Okay. All right. Excellent. Okay. This is my all-time favorite. If your teams can get to build a dog gear on a robot and build multiple powered attachments that click onto your robot. Okay, so again here, this is what your robot looks like. It's got this attachment, and then you click your powered attachments onto this. Okay, and there's my builder dude. He's really got various worm gears, and there's dog gears for the robot. Okay, there are some really cool robot designs which you can use. Okay, interesting. There's also a thing on gears that you can use, but I know it's right at the bottom here, but just have a look. This is a bit of honesty, from garbage to great. Okay, I don't want you to call your team's designs garbage. I rather want to say it's an evolution of your robots. Your first, if you're going to take a team to a competition, your first robot is going to be very basic, but it's functional. All right. We're going to build strong, reliable robots for first year. All right. I guarantee you, your next year, your robots will have a better design or a more effective design. Please, not better, if more effective. All right. More effective, more functional, more reliable. And it's interesting that he gives some honest feedback. So it's good to watch. It's good to see even where the champions have started. You cannot start right at the top. It's got to be an evolution. All right. So that's my dog gears thing that I've explained to you. And there we go. Okay. So this is a really cool exercise that you can do with your learners. Show them the videos. Run the whole video and say, okay, so where do you see the sensors? What is the flow? Is there any decisions? Are there any repetitions? Do you think there's any gearing? Do you think there's any attachments? So each one of these things can come into play. All right. And let the teams analyze it. All right. I'm going to stop here. Tumelo, are there any questions?
So far, no questions yet.
No questions. Any comments in the chat?
No comments yet. Oh, I see there's a hand that's raised. It's Brown Alexander. Over to you.
Dr. Gous, with that claw attachment now, how do you, that means that you have to know what the size of the object that you're going to pick up now. How do you not break a gear on that thing?
How do you not break a gear?
Yes.
That comes with testing.
Okay, but it means you have to know the size of the object. So it doesn't actually, you can't build an attachment that will sort of pick up any size. You have to know what size the object is that it's going to pick up.
So what my teams normally do is they kind of look at everything. You see, there comes to the verb. So how many things do you have to pick up? And then you decide whether you can build one single attachment for all the missions, or do you need to have a modification? Alexander, can I show you an example now?
Yes, Dr. Gous, thanks.
Okay, all right. Yeah, I'll come to that now. All right, so this is just for review. Again, you do the building. So we said the attachments and the sensors, And the programming again, the movement, what moves, is it the robot that moves or the attachment that moves? And then how do we use the sensors? Okay, all right. So that is kind of, so what we've done up until now is we've got a single robot doing a single thing. All right, so it's a line follow robot, it's a maze robot, it's a single task. Okay. What I'm going to show you now is the FLL challenge, and this is the Cargo Connect challenge for this year. Okay, this is I'm going to show you now. I'll put my other camera on. It's a mat, all right, and there's a rule book for each challenge, and it has missions. So it has 16 different missions, all right, all over this mat. Okay, so there are lots of missions. Each mission has a verb. It's a good start. You can combine it for greater efficiency. All right, and then you build these mission models. So you build them, and these are the mission numbers that you have, and they give you in the book. They tell you exactly. So to unload cargo plane, that's the mission you have. You've got to load the container in the plane and then push the cargo door all the way up to start. All right, and this is what you have to do with this one. So it explains it all very well, and dual lock me, it's like double-sided Velcro. So it keeps your mission in place. Okay, I'm going to show you now on the board. All right. It tells you exactly what you have to do. It's right up there, right in the corner. So this is base. You've got a robot's got to go there. This distance is shorter than that distance. All right. That is a long distance. It's got to be worth its points. Okay. Your robot goes up like that. It's got a shorter distance. If the cargo plane has been prepared for unloading and the door rests completely down, you get 20 points. Right. But if it's unloaded and the container is separate, you get another 10 points. So it tells you exactly what your robot has to do. All right. So if as we were doing just now, like the maze touch sensor robot, that's one thing. Okay. And if your robot only had to unload the plane, that is one thing. All right, now we're getting to another level. Now we're saying the robot must be multitasking. So it's got to do a whole lot of missions. And that's why we have the M3, because that's where you need to have a strategy. Okay. So luckily it's got a robot path diagram, so you can scribble all over it. So you can, I usually have Kokies and crayons, and we can plan it. So if your robot goes here and then there and then there and then comes back to base and goes down here and goes back, your robot needs to have a strategy, right? And then you can estimate. So it's not just to get out the maze. This one is to complete a whole lot of different missions, okay? And you've got like 2.5 minutes, okay? And then, of course, there's a scoring. So now not only do we have to only get out the maze, that is one thing. If you're going to do a competition, you've got to choose from all these missions, which ones are you going to do? And you get points for it in a single match. But your robot can come back to base at any time during the 2.5 minutes. Okay. Okay. So now, what I've got here, there are examples of how to tackle these missions. So this Dr. Hino says all 16 Cargo Connect missions, he's done them with a robot educator, but it's not within the 2.5 minutes. So you have to choose which of them you like. Okay, I know there are some teams using the gyro. There is a link there for you. But now the problem comes. You show your teams how experienced teams can get 680 points. Okay, that is not actually that's actually contributing to the learning, because your teams and say, oh, we can't do this, so we can't do this. So I need you to look at both videos, but what I want you to do is to say, what of these missions can we use? All right. And look what are we aiming for? Okay. So to get 680 points, you've got to be a phenomenal team, but watch the video because it gives you some ideas of where we're going. All right. Okay, now I'm going to stop my presentation. I'm going to say you've got to do the quiz, you've got to do the portfolio, and the schedule is out, and then I'm going to stop sharing, and I'm going to ask any questions. Are there any questions? Any other questions that I've missed before I carry on with the robot? Yes. Let me just have a look here. Where is everybody? All right. Okay, so now I'm back here and I'm going to see, okay, whose hands are up? No hands are up. Oh, okay. All right. Any questions? Okay. All right. So on your, okay, let's take one challenge. All right. I actually can't find the luggage. The luggage hangs on here. What the robot needs to do is release the luggage. Okay. So all it needs to do is push this lever here. Okay, can you see it works as a lever? All right. Now to solve that problem, you need an attachment. Okay. To move the chicken requires another attachment. All right. So now what you've got is you've got two attachments on your robot. Okay. So you've got to go out, do something, come back, do another mission, and come back. All right. I'm going to quickly change my camera and just show you quickly. Okay, now I've got a cat walking over here as well. Sorry, cat. Okay. All right.
Rose.
Yes.
Michelle's just said thank you for sharing the challenges. It gives a lot of context to building and programming the robot.
Thank you. Thank you. Yes, and if there are any teams, any schools that want to participate, please let me know. We can definitely talk about it if you'd like to try one of the challenges. Okay. I'm just going to get this camera. Oops, here. This is very weird. Okay. So here is the base where your robot has to start. Okay. And it has, I actually think maybe we need to have another session. I can have a better camera. How's that? Yeah, this is not working here. The sunlight is not on my side. Tumelo, we need to get this other camera sorted out. Okay.
That's right.
Okay. So let me just quickly take my face back again. All right. So really, what I want to really stress is we did one single sensor on Monday and Tuesday. We did a single sensor. All right. The problems that I presented, those 6 examples that were presented, was a single attachment or a single sensor. With following the line, you had a color sensor and an ultrasonic sensor. Okay. So in pulling it all together, you need to really, this cat is not letting me go. What you need to now do is say, now we need a robot that has multiple sensors, multiple attachments, and it needs to have a strategy. So whenever you have a problem, you need to have a problem-solving strategy. All right. And that's when I started right in the beginning to say we divide up the problem. So for a robotics challenge, we take the whole challenge, divide it into missions, and each mission we divide up as well until we get a whole solution. All right. And I really encourage you, go and watch some videos of teams that maybe score high points, but see how they do it. It's about putting it all together. And I'll just kind of end with my example of my team. So what we would do is we would put out the mat and we would look at the list of missions, and then, so there are 8 in the team, and then they usually work 2 by 2 or 3 and 2 or 3 and 3 and 2. What missions would they like to do? Right? And they always were required, if they're in groups of 3, you need to build the attachment for that mission. You need to program that mission. And on the day of the competition, you need to run your robot to complete that mission. So you take ownership for that mission. And every group had at least two. One was really easy, so guaranteed points. And the other part was a little bit more difficult, a little bit more risk, but a challenge. Okay. And so once you've got your guaranteed points, then you take a mission that maybe takes a little bit more risk, a little bit more effort, and a little bit more maybe thinking, maybe design, maybe programming, but that you always have a balance with low risk, guaranteed points, and then a little bit higher risk, and if you pull it off, it's like awesome. Yeah. So and then kind of halfway through, because there's 3 sets of 4 weeks when we prepare for a competition. So the middle part is they're pulling it all together, seeing what everybody has, each part that needs to come together, and then the final 4 weeks we practice the robot up and down, and then we time it to fine-tune the solutions. Okay, in all cases there's never one solution, and if you look at videos of previous FLL challenges, you'll see no 2 robots are the same. No 2 robots are the same, no 2 teams have the same approach. It's a team decision, and it's where strategy comes in. Okay, because we need to solve the problem. You'll get great ideas from videos that are posted. You'll get great ideas, especially so that Dr. Hino always gives you the little robot that can get guaranteed points. Find something there. And then go and be inspired by teams that have got more efficient and more effective robots. And then kind of your team has to be somewhere in between that. All right. Okay, I have spoken a lot. And I am very excited that you've got to the end of Unit 4, because now you've been able to pull it all together. I think it's very difficult if you just have these bits and pieces and you don't know where the whole lot fits together. But there it is. Okay, one robot, 1 sensor, 2 sensors. It's like with maths, 1-digit maths, 2-digit maths, 3-digit maths. So 1 sensor, 2 sensors, 3 sensors, 1 attachment, get it to work properly, and then put another attachment on it, or take that attachment off and put another attachment onto the robot. And at all times, you are improving the efficiency and effectiveness of your robot. Okay. All right. Any other comments? Any other questions? Tumelo?
So far so good from the participants.
Okay.
Yes, no comments so far. No.
So if anybody wants to kind of try out the challenge, there should be a challenge in the hub. We'll set up a challenge in the hub. If anybody wants to come and try it out. Otherwise, I think we do need to have some information sessions of how do you tackle the Cargo Connect challenge. Yeah. All right. Just by way of advertising, I don't know how many of you have seen the advertisement for the first first tech challenge, and that's for high school learners. And we build the bigger robots, the old Meccano sets that we used to build with. So it's kind of in that league, but you can design your own. You can design your own parts. So we can do 3D printing. You can do laser cutting. We remote control our robots. And there's an information sharing session then on Saturday afternoon at 4 o'clock. And I'd love to have you join us. You should have an invitation. If you don't have invitation and you're curious, you're more than welcome to email ISET, and they will send you the invite for the Saturday extra information session. Yeah. All right. I also just on a totally different thing. I do think we need to have some challenge, unpack some challenges. So I'm happy to unpack the WRO challenges as well, just to see how it's done and how it's how do you solve the WRO challenges? Maybe go and look at the maths online and see how would you solve the problem. The problem with one of the challenges with a WRO competition though is that there's only 3 members in a team, and they've changed the rules slightly. So you arrive with a robot. Teams previously needed to memorize the entire design. So if they got the design wrong, then they would be in trouble, because then their programs would not work. So they've changed the rules. There's a really cool, I don't know how many of you play tennis, but there's a really cool RoboSport, 2 robots playing tennis. So I'm looking for some first-year students. Maybe we'll enter a tennis team into the Robots Sports Challenge this year. That's also an option. Okay. Again, it's about multiple sensors, multiple attachments. Okay. All right. I think I've said enough now. Right. Tumelo, any more comments? Any more hands up? I can't see here.
I see someone is typing. Let's wait for that.
Okay.
In the meantime, gentlemen and ladies, kindly please unmute yourselves or raise your hand for any questions that you might have.
And if you're inspired by one of the previous challenges, let me know. Maybe we can organize that you can participate in a previous challenge. Okay. Maybe as a problem-solving exercise, that's also good.
Cleo says, thank you for all the information.
Pleasure.
Really appreciate it.
Pleasure. All right. Okay. We've come to the end of Unit 4 then. All right. I don't see, is Cabello still in his meeting?
Not.
He's not in, hey?
Not.
No. All right. Well, then we'll give Anzani a chance to close the session. How's that?
Great.
Thank you. Anyways, guys, thank you so much. It's been a pleasure once again being with you. And this is the last session for the month of Feb. The schedule for March is out, and hopefully you'll be able to join us again. Invite your friends, colleagues, learners, and so forth, so that they can come and join us, and then we spread the wonderful love of robotics to the entire nation. Thank you so much, guys, and have a lovely, lovely weekend, because tomorrow we will not be seeing you.
Tomorrow's Friday. Thanks, Anzani. Thank you so much. Excellent. Thank you, everybody. I'm waiting for Casper to end the recording. And then we'll have them uploaded over the week.